Good afternoon, we're Team 3. I'm Perez, this is Jose Amador, and this is Aaron Solomon. This is for the robotic design project, or project 2. The overview was that we had to create 3 unique robots to perform 3 specific tasks. The first one was a dance routine in which we selected a song and were able to perform the song with the robot accordingly. The environmental scan did a 360-degree scan of a room, detected the farthest object, and moved towards it. And our open-ended design robot was a specific task created by Jose in which it was to follow light. Now the first robot, which is the dance routine.
Okay, so I was in charge of the dance routine task, and basically I had to program 2 robots to move in sync with a song. The song we chose was the Cha-Cha Slide, and basically some of the limiting problems for this program was the timing. To get it to time in sync with the music was the biggest difficulty. Other than that, the programming itself was pretty basic, for loops, do loops, and one of the major problems that I encountered was probably the battery life of the robots themselves, which caused the robots to move out of sync throughout the performance. Here's a video presentation of that dance routine.
Featuring the Flagler band, and this time we're gonna get funky, 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 funky. Everybody clap your hands, clap, 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 clap your hands, clap, 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 clap your hands. All right, now we're gonna do the basic step. To the left, take it back there, y'all. One up this time. Right foot, let's start. Left foot, let's start. Cha-cha, real smooth. Turn it out. To the left. Take it back there, y'all. One off this time. Right foot, let's start. Left foot, let's start. Cha-cha there, y'all. Now it's time to get funky. All right, all I want to do.
Okay, so as you just previously saw, the 2 robots did move in sync for most of the routine. However, there was some out of sync motions due to the lack of voltage received by the servers due to the difference in battery life. And now I'm going to pass it on to Lewis on the second task.
Second task, as stated before, was to scan nearby environments and distinguish what was the farthest object. This was a tricky task in the sense that I had to know what was an object and what was a wall. That was an issue in with itself. Then after it found the farthest object, it was to move towards the object and stop 2 inches before the object. At this point, once it reached the 2 inches, it would stop, rescan, do the 360 degrees again, and find the farthest object again and move towards it. So now we're going to see a video now that fully demonstrates this robot doing its task. Right there you can see the robot having done its 360 scan. In the 360 scan, we also made it stop, for half a second every time I found the new farthest object. That was the purpose for debugging, so we can notice that it's registering its newest and its farthest object. After that, we had to move the foam out of the way, or else the robot was going to hit the foam. That was the reason for me moving the foam. Other than that, the robot performed impeccably. The next robot is the open-ended design, which is Jose Amador.
For this robot, we decided to use photoresistors to detect light and guide the robot along a determined path that you could adjust based off where you shine the light. The way we did this was we used one sensor on either side of the robot to make it when there was a light being flashed directly above the robot, it would just go straight. And under this condition, if it felt something along the feelers in the front, it would actually stop upon contact. Or if it had a light shining to either the left or the right of the robot, it would turn in that direction. The condition where there would be no light, the robot itself would back up until it eventually found a wall using the sonar, and then it would stop inches from there, and then that would be the stop condition for darkness. Here's a video of the robot in action. Here you see the feelers in action, and as you can tell, whenever the light is shined, the robot is either turning left or right or moving forward. And right there you saw Aaron's hand stopping it, giving it the condition as if it was backing up in the dark. And here you can see it's completely free of the original obstacle course we had set up for it, and showing also the turning capability that you have with the phone. You can use any light that you would want to use as a source to make this happen. And also, assuming we would have had better initial materials for the robot, we could have actually made it so that in regular daylight, it would have behaved as if it was dark. And then during, when you're shining the light directly on it, it would then behave as it did. The issue was that we did not have resistors and enough time to really calibrate the photoresistors so that we got that result. Recommendations for the entire project were primarily to have your own Bobot if possible, for the sake of avoiding inconsistencies when you're actually uploading the code onto the microcontroller. Other alternative improvements you could have made were also to provide fresh batteries for the robots consistently, because the servos themselves were not consistent, depending on battery level and actual deterioration of the robot. And the servo strength is really the primary problem, because you would have, even when giving consistent inputs, in one Bobot it would go straight ahead, in another Bobot it would have a tendency to lean left or right because of the deterioration of the servos. So this is the primary problem with the report product.
Okay, and that's the end of our project. Thank you.